with a quiz if you're watching at home. I'm going to share my screen so you can see that first quiz question. And you should pause your video. And there it is. Pause your video, work that first question out, and then we'll be ready for our next question. You got it? All right, thank you. She greets you a lot nicer than I do. Thank you, Mrs. McCollum. George, we got a little quiz we're taking. Here's your first question. Give you guys about 30 more seconds. Man, you doing all right? Good. I know it's a little rainy today. Glad you're here. George, you good? Awesome. All right, we're taking a little quiz, Jack, so I'll scroll back up to question 1 in just a moment. Here's question number 2. Now this one you'll need a little bit more time on, I reckon, but we're just solving that basic quadratic equation using our square root method. Man, it's dark outside. Don't be looking back in your notes. This is a quiz. Not that the grades really matter in this class, but still, y'all put yourselves to the test. Everybody got that one written down? Okay. Here's our third and final question. Can y'all see that all right? You guys in the back? Y'all see that okay? Quentin, you good? Yeah, I'll zoom in a little bit more. Everybody got this one written down? You don't have to be finished with it. I'm just going to scroll back up for Jack to get that first one. Okay. And I'll give you an outlandish bonus question to wrap things up here. A little OBQ on a Tuesday. Yesterday afternoon, after baseball practice, I took my oldest two kids out on a mountain bike ride. It was Betsy's first time going. There's a local cycling group called the Memphis Hightailers, and they have a little kids ride on Monday nights. And so she went out and with the Little Rippers and had a ball. We just, oh man, it was so fun. And so on the way home, I decided to treat her and Teddy to a little dinner at a restaurant to celebrate her first big girl mountain bike ride. So did we either A, go to a pizza joint, B, go to a burger joint, or C, go to a Mexican joint? So was it either pizza, burgers, or Mexican? We don't get to ask questions about the OBQ though. Is this a math question? You good, George? Oh, sorry. Nate, you may see number 2 again. There's number 2. You good? And then you wanted to see number 3 as well? Okay. Here is number 3. Anybody need more time? Feel free to ask for more time if you need it. Okay. Let's take about another 15 seconds. Trying to wrap this bad boy up. Again, we'll go over this. You guys grade your own. Each question is worth 2 points. This back good? You back good? See? All right, folks. Let's see how we did. So number 1, we talk about our square root method. The first step is what? Yeah, isolate the quadratic term. We will get whatever's being squared by itself. All right, so that we can not raise both sides to the power that matches the root. There is no root, right? In this case, we can take the root of both sides, either square root or cube root or fourth root or fifth root or whatever that might be. So that's where that one is a little bit backwards. Simplifying the radical would be step 3, and check the solutions is step 4. Okay. Number 2, let's work this one out together. All right, Luke, what would my first step be on this one? Correct. We're going to add 5 to both sides. So I get 32. All right. And then, Andrew, next step. By 2, I get x squared equals 16. Alex, next step. Take square root of both sides. So I get x equals what? That a boy. Good. Plus or minus 4, right? And oh, what a tempting thing it is to see that first answer and to just jump on it like a, I don't know what, jump on it like a hungry kid on a cookie, we'll say. But we can't jump the gun and say, oh, 4 is my only answer, because this is a quadratic equation, and we know that quadratic equations always have 2 solutions, right? So that's why it's plus or minus 4, because that intermediate step that we sometimes will skip over, we say, oh, you know what, absolute value of x equals 4. That means 4 is a number that's to the left or to the right. So very good, very good. And then here's our last one right here, number 3. This one had a little bit more of a process to it, right? But still, we're isolating a squared term. We're taking the square root of both sides. So help me get the squared term by itself. Tiago, tell me my first 2 steps. So we got 5 and then parentheses squared over 4 equals 20. Next step. Multiply both sides by 4. 20 times 4 is 80, right? And then Joe Edwards, what should I do next? Divide by 5. Good. So now we've got 3x plus 1 quantity squared. What's 80 divided by 5? Is that 16? Equals 16. And then I'm going to take the square root of both sides. I'm going to get 3x plus 1 equals plus or minus 4. Now this one is where some folks might get stuck and they'd be like, I'm not sure what to do here. Okay. Remember what we said yesterday. We said that if the radical goes away, that I would recommend splitting them. In other words, I would recommend saying 3x plus 1 equals positive 4, or 3x plus 1 equals negative 4. And now those are 2 basic linear equations that we could solve out. Mossy, help me solve those out. What do I do to get x by itself? Nice and loud. And then? Correctamundo. And then if I subtract 1 here, I got negative 5, and then divide by 3. So there are my 2 answers right there, negative 5/3 and positive 1. All right, so I would recommend, again, like I said, when the square root goes away, just split the 2 answers up, right? Because you're going to have rational answers, all right? Not that anybody tried this, but you could have foiled both sides, got all the numbers on one side, done factoring in the ZPP there. That's kind of a longer approach than the square root method, okay? So any questions on 1, 2, or 3 on this quiz? Anybody go 3 for 3? Yeah, okay, not bad. About a third of you guys. Pretty good. The OBQ, what do we think? So we haven't gone to this little Rippers ride in about a year and a half, and Betsy back then was a little bit too young, didn't have a mountain bike, and so Teddy and I used to go all the time, and I would always take Teddy to Pyro's Pizza. Y'all ever go to Pyro's Pizza? I love Pyro's Pizza. Get the breakfast pizza if you go to Pyro's. That's the move right there. You don't like their crust? Well, you can just get out, Paul. Seriously, get. But because Betsy was with us last night, I let Betsy choose. And Betsy's favorite place to go is El Nopal. El Nopal. ¿Cómo se dice El Nopal en inglés? ¿Cómo se dice? How do you say El Nopal en inglés? In other words, in English. The Nopal. Nopal means cactus. It's the cactus. We like to go there. It's a place in Oakland. And man, it was so flippin' good. Teddy and I shared what's called the Mazatlan burrito. Okay, and it's a burrito that I'm not joking you, it's as big as my forearm is. It's ginormous, takes up the whole plate. It's got beef, chicken, rice, beans, guacamole, and bacon in it. And it's covered in cheese dip. It is so good. And then Betsy had her normal plate of beans, and we got some cheese dip, and we shared it. Just good little daddy time, man. Good little daddy time. You guys ever go on little you don't want to call it a date with your daddy or whatever, but you ever go out with your dad, do anything father son stuff? And yeah, you ought to do it. I'm telling you, you guys ever do that with your mom? You ever go out to lunch with your mom or something like that? Okay, do it, man. It's awesome. It's fun. All right, so I digress. You gave yourself a score. I'm not going to record any of those scores, but anybody with because the OBQ is only worth 1 point. Anybody with a 5 or a 6 or a 7? Anybody with a 5 or better on that quiz? Raise your hand in the air. Let me kind of see. 2 points per question. Ding, ding, ding. Okay, not too bad, not too bad. So, from my understanding, then we feel as a whole, we feel like we're comfortable with this material. Let me help you get a little bit more comfortable with it. Okay, there's this thing that we have called a textbook, and yesterday you guys left out of here, and y'all had done what in our notes? I think we had done like 3 examples, right? Like I would do one, and then you would do one, and then I would do one, and then you would do one. Like yeah, y'all did maybe like 2 or 3 examples. You think 2 or 3 examples is enough? No, 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 no. If you want to get real good at something, you got to practice it. So, like, we've got our textbook, and you guys are right down here in chapter 9, quadratic equations, and that was section what? 9.9.1. So, all you got to do to practice, right, is go to your textbook and scroll down to the very bottom once it pulls up. Scroll down to the very bottom, and then you got a boatload. Again, it'll come up here in a second. There we go. You've got a boatload of examples, and we've talked about this before, where the odd ones are in the back. The answers are in the back, so you can practice to your little heart's content. I look for Delta Math assignments. Some of you guys are pretty good about being diligent and doing those. Others not so much. But always, be looking on that Delta Math as well, because I will sometimes put some actual assignments on there as you guys need some practice. Okay. Now, today we are going to jump into a new lesson. Okay, this is lesson 9.2, and it is called, quote, completing the square. We're going to talk about completing the square today, Thursday, and again on Friday. It's a big fat hairy deal. Okay, it's called completing the square. Yesterday in class, you guys had a warm-up question where I asked you to factor a PST. I asked you to factor a perfect square trinomial, right? You're like, oh, wait, I don't remember that. Just in your notes, you go back to number 3 on the warm-ups yesterday. That's what a PST looks like. That's what a perfect square trinomial factorization looks like. Somebody, it was either in my first period or in you guys' class, somebody factored out using the magic method, and we said, that's fine. You can get it done that way, but I would prefer doing the perfect square trinomial factorization technique. Well, I've got that general template in black at the top of your screen. That's the general template for factoring a PST, okay? So a squared plus 2ab plus b squared generally factors out as a plus b quantity squared, okay? So in example 1 today, we're going to sort of investigate a little bit further about our perfect square trinomials. We're going to see, well, what makes something a perfect square trinomial? All right. So look in orange right there and see if you could tell me what would make this a PST. What would make this trinomial a perfect square trinomial? In other words, fill in the blank. All right. I saw James's hand. Go for it, James. Louder. 25. Good. I thought you said 45 for a sec. 25 is absolutely right. If I put 25 there, George, could you factor that out for us? So over on the right, I should say what in the parentheses? Good. X plus 5 quantity squared. That's pretty easy. That makes pretty good sense, hopefully. Okay. Again, the slow way of doing that, like the show your steps kind of way, is if I said x times x, and if I said 5 times 5, and circle, bless you. You multiply these two together, you get 5x, you double that, you get 10x. That's what's in the middle, so we know that's a perfect square trinomial, and that's how it factors out. X plus 5 quantity squared. Okay. Somebody else down here in blue. What do you think? So I got James to help me on the first one there. Jack, you want to do the next one? What goes in the blank there? 81. Ooh, 81. Okay. And so, Grove, I think, did I see your hand up? Okay, Grove, could you help me factor this out? In other words, what goes in the blank over there for my parentheses? 9. All right, what kind of 9? Positive. Are you positive? Yes. All right, it's going to be a negative. All right. And could you, let's see here. There's none. Circle, circle. Reed, could you tell me why it should be negative? Good, because the 18 is negative. Remember, fellas, when we're factoring, we are doing which process backwards? Good. Who said that? Jack? When we're factoring, we are unfoiling. Okay? It's like yesterday morning I cooked some bacon. I didn't have a gallon-sized Ziploc bag, which I normally use to put my bacon in when I'm, you ever open a package of bacon? They're like unless you pay high dollar for like the Wright brand bacon, Wright brand bacon, you guys know what I'm talking about? Y'all ever shop for bacon? I don't have any bacon aficionados up in here. Mr. Went is. He knows what I'm talking about. Anyway, so like you get normal like Kroger brand bacon. It's in like this vacuum sealed pack. And boy, once you open that up, there's no closing it back. So normally you got to put it in like a Ziploc pouch unless you're going to cook it all. And who cooks 2 daggum pounds of bacon on a Monday morning? Not this guy. So I just cooked a couple strips. I needed to be able to store my bacon, and yet I'm out of Ziploc bags. So I got some aluminum foil, right? And just wrap that bad boy up in my aluminum foil. Well, today, to cook my bacon, what did I have to do? I had to unfoil it, had to open it up. What we're doing here, quote, quote, when we're factoring is we are unfoiling it. So to check to make sure that Grove is correct, I would foil this back out, okay? Wait, what do I? Excuse me, thank you. The way that we would check this is we would multiply x minus 9 times x minus 9, and then the outer would be negative 9x, the inner would be negative 9x, and that makes for the negative 18x. All right. Now, it might feel like I'm beating a dead horse here, but this is an important point to make. All right. So now in green is the challenge question. Now in green is the question that you're like, huh? But I want to see if you can figure out on your own. I'll give you a minute to think about it. I want to see if you can figure out the pattern, where these guys came up with the 25 in orange and the 81 in blue. Where did those come from in the problem? And therefore, can I follow that same pattern here in green? Okay, so you got 60 seconds to think about that. About 10 more seconds. Anybody got an idea they want to share? Anybody got a thought? Tiago? All right, so if it's b squared, it's a good place to start. Let me just zoom in here and do a little bit of extra space. All right, so we're going to say b squared. Now, if that's the case, then I should be able to split this up, circle, circle. And what is my check? Like up here in blue, I had x times 9 is 9x. Double it, and you get what's in the middle. So x times b is bx. Double it. Ooh, I don't have 2bx in the middle, but I'm close. Tiago's got me going in the right direction. Let's see here. William, what do you think? All right. So 1/2 b squared. I'm going to write it as b over 2 squared. Okay. Or did you mean 1/2 and then times and then b is the only thing being squared? Which one did you mean? You want to square the half and the b or only the b? Only the b. All right. Poor choice. But we'll do it. So what you're saying is 1/2 times b squared, right? All right, so how do I split this up? In other words, that's my issue, right? What times itself equals 1/2? 1 over square root of 2, 1 over square root of 2. We don't want to do that, do we? So let's square the 1/2 too. Let's square the 1/2 also. So in other words, let's have it like this, or better yet, as I had written it a moment ago, b over 2 times b over 2. Like, so we split that up and we get b over 2 times b over 2. All right. Now, what do you guys think? Does it work out? Okay. X times b over 2 doubled. The 2 would cancel out, and I'd be left with bx. So how would that factor? So we've got our PST. How would that factor out? Over here in the parentheses, I would say x plus b over 2. And the reason the green one is a lot harder than the orange one and the blue one is what? Yeah, I didn't catch who said that. Yeah, it's variables, letters, generalization, okay? So we could do the orange one and the blue one until the daggone cows come home. But if we are really savvy about what the process entails, then we can do it in general form. In other words, where there's not a specific number. Now, I've kind of been letting you sort of discover this pattern, right? What was this pattern? Like Tiago and William, what did they do to the 25 and to the 81 to kind of follow in this pattern? What were they doing to them? I'll give you a hint. It involves what we learned about yesterday and what you guys took a quiz on. What about 25 and what about 81? The square root, okay? So what we are discovering is that we're trying to think of what number has a square root that when doubled equals this. I'll ask that question again. That's the mental question that we were trying to ask. What number when doubled has a square root? No, what number whose square root when doubled equals 10x or equals 18x? And that's kind of the process that we're going by. This mental process is known as, quote, completing the square. And this is what I'll have to leave you with today. In the box at the top of your screen are 3 steps to completing the square. In other words, if you follow these 3 steps, you will be able to fill in the blank. You will be able to turn these into perfect square trinomials. Okay, you'll be able to turn all of these into perfect square trinomials. The first step is to consider what the linear coefficient is, right? Joey, that's some fancy words right there, linear coefficient. I don't know if I remember what that means. Help me remember. What is linear coefficient? Nice and loud. The first number. So in red there, what's your linear coefficient? Good, 6. All right, so let's say it perhaps a little bit more elegantly than Joey said it, but he's correct that 6 is the linear coefficient. In blue, negative 22 is the linear coefficient. In green, 34 is the linear coefficient. In orange, 3 is the linear coefficient. In other words, the linear term is the term where it's x to the first power, and coefficient just means what? What is a coefficient? A number in front of a variable, okay? Please don't forget that when you take Coach Ligon's biology class, if y'all take his class. He was harping on that the other day. He was like, man, these dadgum sophomores don't know what a coefficient is. I'm like, well, what are you going to do? All right, so if the idea of step number 1 is to consider what the linear coefficient is, step 2 then says just cut that in half. Okay, so in red, what's the linear coefficient? 6. We cut that in half, we get 3. And then the third step says square the result. So I would put a what? I would put a 9 in red. All right. And now this constitutes a PST. This constitutes a perfect square trinomial, which is very easily factorable as x plus 3 times x plus 3. You know what I'm saying? And we don't have to split and write x, and split and write 3, 3. We daggum know it factors that way because that's how we made it. We made it to factor that way. All right? Why don't you try the blue one? Okay, why don't you try the blue one? I know we're out of time, but go ahead and do the blue one real quick. Fill in the blank and factor it. We'll get Drew to fill in the blank, and we'll get Ben to factor it. So consider your linear coefficient, cut that in half, square that, and then we can factor. Drew, whenever you're ready, tell us what goes in the blank. You need a nudge in the right direction. What's your linear coefficient in blue? Good. Can you cut that in half? Can you square that? That's what goes in the blank, my man. 121. Again, fellas, it's just, hey, I'm following these 3 steps. Okay, very good. So, Ben, Rouse, can you factor that for us, please? How does that factor? Dude, you are the man.com. And with that, fellas, I will leave you till tomorrow, or excuse me, till Thursday. Live Jesus in our hearts. Y'all be real safe out there in the rain. Thanks again for a good class. And y'all keep practicing, okay? Keep getting better. Y'all be safe out there in the rain, guys.